Alright, it's been a while since I've done an update for this, so here we go. Aside from the usual, just implementing new things, not a lot has changed on the visual side of this program. You can see that it's quite similar to the last video, other than rotations. I've implemented rotations, although they're a bit buggy. You might notice that from some of these objects flying around. They don't look very natural. Although the code for rotations is correct, the data which is given into that code isn't. It's just a whack job that I put together quickly, and sometimes it works, sometimes it doesn't. Usually if objects are further away from the center point of the two objects colliding, the more extreme the rotations will be. So you'll see objects collide, rotate normally, and then collide again and go crazy. That's the reason why. But enough of that. What have I done since the last video? You may notice up here we've got two clocks running now. One clock runs the FPS, the graphics side of the program, and the other is the physics clock, which handles exclusively the physics aspect of the code. What this means is that the graphics and the physics are already on two separate threads, meaning they won't interfere with each other performance-wise. And on top of that, the entire program is fully multi-threaded. If I bring over a core manager, aha, look at this. Everything is divided equally among all the cores. You can see that. SimFiz using all the cores, all the CPU is the only, and it's spread out evenly across here. So performance-wise, I'm very happy with it at the moment. It's not laggy at all, even though there are hundreds of collisions per second with all these objects just resting on place. Now, to make it a lot faster, what I have done is had to implement a 3D hulling algorithm for all the components, which are the shapes in the scene. What this does is reduce the number of vertices on each shape by a drastic amount, allowing the collision algorithm to be far more smooth and faster than it was without the algorithm. You can see here these are the cubes, 24 vertices converted to 8, which would be what you would expect for a cube. Come down here for some of the more complex shapes, 2,500 vertices down to 400, so it's quite a drastic reduction in vertices which the algorithm has to now loop over, making it very fast. And same for normals. Any unique normals are collected, but any duplicates are discarded, so that also increases the speed of the algorithm. And again for the other shape. And I can show you this by drawing the 3D hulls. Just start it up again. At the moment, this whole generation isn't multi-threaded, so it has to go through one by one and build them, but it's still quite fast. Each one of these dots is an iteration over the whole building algorithm. And there's the teapot, the star shape, and the arrow. Now, the faces of triangles are missing. That's just because I didn't bother to correct it. What is important is all the points, or all the vertices are correct, and that is true for all these shapes because the collision algorithm only works off the vertices. It doesn't care about the faces at all. So that's why I'm not too worried about fixing up missing faces. And yeah, that's about it. I'll be fixing up rotations soon so they are more realistic. That shouldn't be too much work. All I need to do is fix how I collect the data from the collision. At the moment I'm using the GJK algorithm and it works pretty good at the moment, but my code for finding the collision point and normal still needs a bit of tweaking, and once that's fixed the rotations should solve themselves. That's it. Stay tuned for another update.